let's let's look at how the exchange of radiation energy happens between the gray and diffuse surfaces. Let's say we have a surface here. We know that if there is a G showing an incident radiation, so G is incident radiation, part of that is getting reflected from the surface. So let's assume rho G, rho is the reflectivity, is reflected radiation. And a gray surface can also emit energy at its temperature as a fraction of what the black body can emit. So let's say this is showing epsilon was the emissivity, that ratio EB, and that is the emitted energy. Now these two were the terms as we were referring by radiosity, and we're showing that by J. So let's say for surface I, that is gray and non-transparent. It is gray, so epsilon I is equal to alpha I, and alpha I plus rho I is going to be 1 for the surface I. So non-transparent and gray surface. Now the radiosity we can define that, let's say the J from the surface I is going to be radiation emitted by the surface I plus radiation reflected by surface I. So in terms of formulation, we are emitting radiation by epsilon I EBI. I indicates the surface that we are looking at, and reflectivity rho I GI, the incident to that surface. So it's going to be epsilon I EBI, and this is a gray and non-transparent, so rho I is going to be 1 minus alpha I, or 1 minus epsilon I GI. For a black body, just a reminder, recall that for black body epsilon I was 1. So what does that mean? J is equal to EBI, which is sigma Ti to the power of 4. So this is the J radiosity for the gray and non-transparent surface. Now let's look at the net radiation. Net radiation heat transfer from a surface or to a surface. Let's call it surface I again. So the net radiation from a surface or to surface, let's show it by Qi, is radiation leaving the surface, radiation leaving the entire surface I, minus radiation incident or receiving an entire surface I. So what is leaving for the entire surface is AI. What is leaving is radiosity that we are looking at, Ji, minus what is receiving or incident is Gi. And we know this radiosity from the top for a gray surface is ji is eb epsilon I ebi plus 1 minus epsilon I gi. From here, I can find the incident radiation to a surface. Gi is going to be ji minus epsilon I ebi divided by 1 minus epsilon I. Now, if I replace this one here, so these two, what they give me here is qi is ai ji minus epsilon I ebi 1 minus epsilon I, which I do a little bit of rearrangement here. It will be ai epsilon I 1 minus epsilon I times ebi minus ji. And if I just reformat that one, it's going to be ebi minus ji divided by 1 minus epsilon I ai, or ebi minus ji divided by ri, where this looks as a form of resistance. And if I want to just schematize that one, let's say this is surface I. ebi is what a black body can emit. So here what we have is ebi, and since it's a gray surface and diffuse surface, now what we have, we take into account everything in terms of a resistance. It acts as a resistant. So we can assume, let's say this gray surface is a black surface, but there is an extra resistance to the flow. So this is the resistance. We show it by ri, which is 1 minus epsilon I ai. And here we have ji. Now from ji, it could go to the different surfaces that we have. So really, this is the general picture that we have when we are dealing with the real surfaces or with the gray surface. The same thing now, we can look at the net radiation heat transfer between two surfaces, radiation heat transfer between two gray surfaces or between two surfaces. Now let's say we have two gray surfaces, surface 1 and surface 2. So let's say this is, or let's call this one surface, just to make it general, surface J, and this is surface I. Now, the way we treat this problem is we can assume this is ebi, energy in the form of a black body. There is this resistance here, Ri, and then another resistance because of the view factor and geometrical concentration, and another one which is Rj. So here is Ri, this node is Ji, this node is Jj, and this resistor is Rj, Ri, and this one is Rij. Now I'm going to write down and mention what is this Rij. So we know that Qij, we have seen it, it's going to be ai Fij Ji minus Aj Fji Jj. Okay, so for surface I and surface J. Now recall that there is a relationship between these two. J is JFJI. So Qij would be AI Fij Ji minus Jj. Radiosity of surface R, the difference between I and J. So I can rewrite that one in terms of Ji minus Jj divided by 1 over AI Fij. This is what we call it Rij, which is 1 over AI Fij, which is the space resistance to radiation. Now, this is between two surfaces. If we have a enclosure with n surfaces, so for an n surface enclosure, let's say we have an enclosure with multiple surfaces and we want to look at the radiation or the radiation energy from surface I to the rest of them. So let's say this is just representing the surface I of that enclosure. Then this is EBI. We have RI here, and here is node JI. Now from node JI, we would have radiation to the different surfaces. Let's say to the surface 1, this is going to be J1 with the RI1. Let's say this is surface 2, J2, RI2, and multiple surfaces. So let's say this is JN, this is RIN. So this is how we can write it down. Now the QI, there is a QI here. In fact, I missed pointing that on the other ones too. So there is a really like a heat transfer, let's say QI that is going, and the same thing here too. So QI here is going to be the summation of everything that is leaving the surface and receiving by the other surfaces. So QI, if I just look at the first two, is going to be EBI minus JI divided by RI. Now I'm at this point, so this QI is just getting divided among all of them. So it's going to be the summation of JI minus JJ divided by Rij, where J is changing from 1 to n.